Hello, this is Mr. Ensler, and I'm going to go through your Chapter 1 review for geometry for our first test. Feel free to skip around, fast forward, and rewind to get to the problems that you want to get to. So I'll start at the beginning here. Number 1, find 3 points that are collinear. Alright, collinear. That means all on the same line. So if I look on this line here, I don't have 3 points. I have A and I have Q. G is not a point. It's the name of this line. On the other line, I have A, Z, and R. So there we go. A, Z, and R. A, Z, and R. All right, number 2. Write 3 different names for line P. Okay, so this is line P, and I know that because it has this small italicized letter. So we can just choose any 2 letters in any order and put the line symbol over it. So I could say AZ and put the little line symbol over it. I could say ZA with the line symbol over it. I could say ZR, and that's the exact same line, and I could say RZ. I could also say AR and RA. Any of those are actually referring to the exact same line. Alright, number 3. Name a point not coplanar with M, R, or Z. So here's M, R, and Z, not coplanar. So it can't be on this plane. And the only point that's clearly not on this plane is point Q, because you can see this line is rising up straight through the plane to a level that's above the plane. D, I don't know if D is really on the same plane or if it's up in the air. We don't really have any indication, so Q is the best answer for this question. What is the intersection, number 4, of line AQ and line ZR? So line AQ and line ZR. Well, what makes up their intersection? Point A, and just point A. All right. 5, 6, 7, 8. Find the indicated length. So number 5 is saying find DE. With a problem like this, actually before I start answering individual questions, it could be helpful to just try and figure everything out. Sometimes I find that more helpful. So actually if I look at the first 3 segments, do you see that little line there? That means they're all congruent. AB is the same as BC, is the same as CD. And since they total 18, if I do 18 divided by 3, I get 6. So that means this is 6, this is 6, and this is 6. Now I know the whole thing is 27, so if I do 27 minus 18, I get 9, so this segment is 9. Now I can answer all these questions pretty easily. So DE, number 5, from D to E, that is 9. Number 6, the distance from A to B is 6. Number 7, the distance from B to D, well, that's 6 and 6, so that makes 12. Number 8, the distance from C to E, that's 6 plus 9, so 15. Alright, the next few problems involve the midpoint and the distance formula. Actually, 9, 10, 11, 12 are all about the distance formula. And the directions say, find the exact and approximate distance between the points. So just like we did in class. So you're going to need a calculator for this, but we'll find the exact distance first. So using the distance formula, I'm going to subtract my x's, subtract my y's. It really doesn't matter which order you subtract in. So I'll just do it in order from left to right. So 2 minus 5 squared plus parentheses 3 minus negative 1 squared. Okay. 2 minus 5 is negative 3 squared. 3 minus negative 1 is positive 4. Alright, so now I need to square both of those. The important thing to realize here is that when you square them, they're both going to come out positive. So this is going to be 9 plus 16, which equals square root of 25. And that one actually comes out evenly to 5. So here, I don't have both an exact and approximate. It just happens to work out evenly. Alright, on to the next one. So I'll do 4 minus negative 8 squared for x's. Negative 7 minus negative 2 squared for y. So yeah, watch all those negatives there. So for the x's, 4 minus negative 8, that's going to be positive 12 squared. And for the y's, negative 7 minus negative 2, that's really negative 7 plus 2. So it's going to be negative 5 squared. So that is 144 plus 25, which is 169. Hey, that one actually works out evenly also. If you enter that into the calculator, it comes out exactly to 13. All right. Numbers 11 and 12. So, set up the same way. This time I'll do 3 minus negative 1, just to show you that you can subtract in either order. And so then I'll do 10 minus 5 for the y's. So that's going to be 4 squared plus 5 squared. And so that's what, 16 and 25? Okay, so this one does not come out evenly. This equals square root of 41. So there's my exact answer, because I can't simplify that anymore. Now if I take my calculator and enter in square root 41, it's going to give me an approximate answer of I'll round to two places, 6.40. So I have two answers, an exact and an approximate answer. And we'll set up number 12 here. Again, I'll do, I don't know what that was. I'll do 5 minus 7 for the x's. I'll do 9 minus 1 for the y's. You can go in any order. It really doesn't matter. As long as you do the x minus x and y minus y. So this is going to be negative 2 squared plus 8 squared. So that's going to be 4 plus 64, which is square root of 68. Alright, now, that doesn't come out evenly, but it can be simplified. If you divide 68 by 4, it comes out evenly. Let me bring this up here. So I can split this into square root of 4, square root of 17. That's something you did last year, you should remember. So my exact answer is going to be 2 radical 17. And if I enter that into the calculator, 2 times radical 17, or just enter in square root 68, they're the same number. One is just simplified and the other is not. I get 8.25 if I'm rounding correctly, so approximately 8.25. Alright, on to the next page. We're using the midpoint formula, so you may need to go back and look at that formula on the first page. But basically all you do is you add your two x values, so negative 9 and 2, and divide them by 2, and then do the same thing with the y's. Add the two y values, divide those by 2. So let's see here, I'm going to get negative 7 over 2 and negative 4 over 2, and just want to simplify those all the way. So that's going to be negative 3.5 and negative 2. That's the midpoint between those 2 points. Alright, we'll set number 14 up kind of the same way. So add the x's, 3 plus negative 5 over 2. Apologize for my handwriting, it's kind of hard to write neatly on the iPad here, but I hope you can make out the numbers. So for the y, 0 plus 5 divided by 2. So what will we have? We'll have negative 2 over 2 and positive 5 over 2. So that's going to be negative 1 and 2.5. So that's how you use the midpoint formula. Alright, next set of problems. We have all these points and they say they're collinear, and they're going to give us a few numbers here. So P to S, the whole thing I guess, is 46. You don't have to label it. I find it helpful though, it gives me a visual picture. From P to R is 18. And PQ equals QR. PQ equals QR. So that's where I can put these little congruence markings in. And pretty much right away I'm going to realize that if from P to R is 18 and these are the same, then each of one of these is going to be 9. So I'll just go ahead and label that. While I'm at it, I know I haven't answered any questions yet, but while I'm at it, let's find the distance from R to S, and I can just do 46 minus 18. So 46 minus 18, and that's 28. So I'm just showing how I got that number. And now I can answer the questions pretty easily. So PQ, that's just 9. QR, that's also 9. QS, all right, so if you look at Q to S, I actually have to add 9 plus 28. So that's 37. And then from R to S, we figured that out was 28. All right, on to some angle problems. They're telling us here that angle JKL, that's the whole thing, is 70 degrees. I'm just going to write a little note to myself, that's 70 degrees. And we need to find MKL. So just this one right here. Well, before I do that, I need to find out what X is. And so this is a case where these two angles add together to equal 70 degrees. So I'll just set them up, make an equation equal 70 degrees. All right, my X and 4X makes 5X. 31 and 9 makes 40. And I'm just solving this equation. I'll subtract 40 from both sides, so I get 5x equals 30. And then divide by 5, and x equals 6. Now you don't want to circle your answer here because you're not done. The original question says find the measure of angle MKL. So we want to plug 6 in for x right here. So I'm really going to have 4 times 6 plus 9. So that's 24 plus 9. Add those together and I get 33 degrees. That's the answer I want. All right, number 20. BD bisects ABC. All right, that's important here. This phrase bisects, because that means it splits it exactly in half. That means this angle and this angle are equal. So we can write that out in math. We set up an equation, 11x minus 12 equals 8x plus 3. Now we'll solve this little equation, so I'll subtract 8x from both sides. Then I'll add 12, so I get 3x equals 15, and so you can see x equals 5. And I didn't even read the question, really. All I said is that it bisects. Well, here's what we have to find. Find the measure of ABC. So that's the whole thing. All right, so I'm going to plug it into one of them. I'll just plug it into the second angle, 8x plus 3. So when I do that, 8 times 5 plus 3, I'm going to get 43 degrees, but that's not my answer. 43 degrees is only this angle right here, and ABC is the whole thing. So that means this is 43 degrees too, because we know those two are congruent. So add them together and you get 86 degrees as your total answer. Okay, next we have some perimeter and area problems. And I like to call these backwards problems because it's like they're giving us the answer. In 21, they're telling us what the perimeter is. In 22, we know what the area is, and same with 23. What we don't know is one of the components. Like in number 21, we need to find the length. So what you want to do here is take the original formula for whatever it is they're telling you. So number 21, perimeter equals 2 times the length plus 2 times the width. So that's the original perimeter formula. And then we'll just fill in what we know. We know the perimeter is 84. We don't know what the length is. We do know the width is 13. So 2 times 13 is 26. So then we'll subtract 26 from each side. We'll just solve this equation now. 84 minus 26 is 58. Then divide both sides by 2, and the length is 29 feet. All right, with number 22, this is a rectangle, and they're telling us the area. So the area of a rectangle in general is just length times width, and they're telling us the area is 432. and the length is 24, and we don't know what the width is. So I'll just divide both sides by 24, 432 divided by 24, and I get 18. So the width equals 18, and that would be meters. Alright, and then number 23. The area of the triangle is 189, find the height. And the thing to realize about this is that notice that this part is shaded of the triangle. That's because that's really the only triangle that we're talking about here. This other white triangle over here, that's not really a triangle. I mean, it is, but all they're doing is they're showing us that the height of the triangle is from down here to up here. So that 15 you see there is extraneous information. In other words, don't use that 15. We don't need it. We're not trying to find the area of the entire big triangle like that, just the shaded area triangle. So if we start off with the formula, one area equals 1/2 base times height. Well, they're giving us the answer is 189. The base is just 21, and we don't know what the height is. So first I would do 1/2 times 21, and there you get 10.5, and then I would divide both sides by 10.5, which really means I'm going to take my calculator and type in 189 divided by 10.5, and I get 18, and that would be centimeters, so height of 18 centimeters. Okay, the next three problems are talking about complementary angles, and the thing to know about complementary angles is that complementary angles add up to 90 degrees. So if angle 1's 31, what's the other angle that would be complementary with it? You can just do 90 minus 31, and we're calling this other angle angle 2, and that equals 59 degrees. That would be the complement. Angle 1 is 10 degrees. Well, what other angle would form 90 degrees with that? That would have to be an 80 degree angle. Number 26. If the first angle is 68 degrees, what would be the second one? Well, you just do 90 minus 68, and you would get 22. So the measure of angle 2 is 22 degrees. The next three are the same except supplementary. Supplementary angles add up to 180. So you have to know the difference between those terms. And so if I have an angle of 114, I could do 180 minus 114, and that will tell me the measure of angle 4, because it says 3 and 4 go together. They're supplementary. So that's 66 degrees. So number 28. 31 and what other angle add up to 180? Well, you just subtract to figure that out. And 180 minus 31 is 149 degrees. And number 29 here, well, what other angle with 90 adds up to 180? Well, that would actually be 90 degrees. Two 90-degree angles add up to 180. Okay, number 30. What is the area of a round pizza that is 15 inches in diameter? Give both the exact and approximate answers. All right, you don't have to do this, but it might be helpful to draw a little picture. So there's our round pizza, 15 inches in diameter. Okay, and so for area, the area of any circle is pi r squared. And so you have to know that the radius is not 15, the radius is half of 15, 7.5. So I'll go ahead and put this in. Area equals pi times 7.5 squared. Now to find the exact answer, you're just going to do 7.5 squared. So type that in your calculator and you get 56.25. So the exact answer is 56.25 pi square inches. And then the approximate answer is where we will type that in and round it out. So 56.25 times, and then use the pi button. Instead of 3.14, use the pi button. and it's approximately 176.71 square inches. And again, what that means is in a 15-inch pizza, in a large pizza, you could have 176, almost 177 little 1 by 1 squares that would fit inside of it. What about the circumference? Well, the circumference formula is pi times diameter. So that would be 15 times pi. And that would be the exact circumference, 15 pi inches. To find the approximate, you want to type 15 times pi into your calculator. And the approximate circumference is 47.12 inches. That's the approximate value. Okay, at the bottom of this page, we want you to know, as in memorize, some common polygon names. So, a 3-sided polygon, that is a triangle. A 4-sided polygon is called a quadrilateral. A 5-sided is a pentagon. A 6-sided is a hexagon. A 7-sided polygon is called a heptagon. An 8-side, you know, is called an octagon. A 9-sided one, that is called a nonagon. Nonagon. 10-sided is called a decagon. A 12-sided is a dodecagon. And then after that, I would say those are the common ones that you should have memorized, you should know by name. But any other ones, even though there might be names for them, we don't memorize that. So like a 19-sided polygon, we would just say a 19gon. And that's what we would do. All right. On the top of the next page, tell if the figure is a polygon. If so, classify it by its number of sides. Is it convex or concave? So number 32, yes, it is a polygon. It has 5 sides, so we would call that a pentagon. And it's convex. Convex, I often think of as going all outward. It doesn't go in on itself, whereas concave kind of caves in on itself. The official definition of convex is that if you can extend the lines that make up the polygon, and if none of them go through the middle of the polygon, then it's convex. So you see how when I extended those lines, they're all going outward, none of them go on the inside, so it's convex. Okay, this next one, this arrow, might not look like a polygon, but if you count the number of sides, there are 7, and they're all straight lines. So yes, this is a heptagon, and this is concave. You can see how it kind of caves in on itself. If I extended this line here, it crosses right through. Same with this one, and some others also. The next one, this kind of sideways heart, is not a polygon because it has curves. And polygons are only made up of straight segments, line segments. Alright, this last one, this kind of sideways T, it is a polygon, we can see. How many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. It might not be what you think of as an octagon, but it does have 8 sides. And this is concave. You can see how it caves in on itself. These sides, if you extend them, they go through the middle of the shape. Alright, next up. Tell whether the angles are vertical, linear, or neither. So let's just do a quick review of these. Vertical angles are across the x from each other. So a perfect example of that would be 5 and 8. Angles 5 and 8, see how they're right across the x from each other? And so 5 and 8 are a good example of vertical angles. It's also good to know that vertical angles are congruent. So 5 and 8 are also congruent angles. They have the same measure. So 4 and 9 are also vertical. See how they're across the x from each other? So what about a linear pair? Well, 4 and 5 are a really good example of a linear pair because they're the only two angles on this part of the line, and together they make up 180 degrees, and they're right next to each other. So they are a linear pair. The other ones, number 33 and 34, are both neither, just because they're not vertical and they're not a linear pair. All right, then let's do some practice with the protractor here. So give the measure and then also classify the angle. Tell whether it's acute, obtuse, right, or straight. So let's look at this, DAC. And you actually want to kind of trace this out either with your finger or the pencil or your eyes. So DAC, right here. First thing I would do is actually classify this. You know this would be a 90-degree angle if it went up to 90, but this is smaller. You can see it's not quite 90. So if it's smaller than 90, that means it's acute. And so when you look at the measurements on the scale, you see it's either right between 70 and 80 or between 100 and 110. And the fact that we know it's acute tells us it's going to be right between 70 and 80. And it's kind of hard to see exactly what it is, but it looks like 75 degrees. You know, I don't know. If you look closely, maybe it's really 74 or 76, but I'm not testing on your eyesight here. So 75 degrees is right. All right, next one, BAC. So trace that, BAC. Hopefully you can just kind of see that that's an acute angle. There's no way that that's 90 degrees. So that's acute also. And how do you figure out this measurement? Well, you can't simply look at one side and figure it out. What you have to do is subtract. And you can either look at the upper scale, so this is like 105 minus 60. So you could do that. 105 minus 60 is 45 degrees. Or you could look at the lower scale. You have 120 and 75. And if you did it that way, you should get the same answer also. 120 minus 75, that's also 45 degrees. Okay, on to EAD. EAD, let's see where that is. EAD. Oh, I just went across in a straight line, so that is a 180 degree angle, which we call a straight angle, because it really just makes a straight line. And then lastly, we have EAB. 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 Okay, so we can, first of all, see that that is an acute angle. So I'm going to write that, acute. And if I follow ray B up there, I can see that it crosses through 120 and 60. Well, it's acute, so it's going to have to be the 60-degree angle. All right, and our last four answers, last four problems here, says find the perimeter or circumference and the area. Give both the exact and approximate answers if necessary. All right, so both perimeter and the area. So number 42, we can see this is a rectangle, and so the formula is 2 times the length plus 2 times the width. So, and that's for perimeter. So I'm going to get 30 and 12. So the perimeter is 42 feet. The area of a rectangle is length times width. So area equals 15 times 6, and that is 90. So 90 square feet. We could fit 90 1 foot by 1 foot squares in that rectangle. All right, let's take a look at number 43. Uh-oh, we have fractions, but you know what? You can use your calculator, so it shouldn't be that big of a deal. For the perimeter, we don't have a special formula for a triangle. You just add up the sides. So 5/9 plus 4/9 plus 1/4. Actually, I don't even think you need a calculator for this, because if you look at the first two, 5/9 and 4/9, if you add those together, that makes 9/9, which is 1. So really, the perimeter is 1 1/4 inches. Just leave it there as a mixed number. As for the area of any triangle is 1/2 base times height. Well, I'm going to use 1/4 as the base, and the height is perpendicular to it. So you see this little perpendicular line. So if 1/4 is the base, 4/9 would be the height. So So 1/2 times 1/4 times 4/9. I don't know if you remember this, that you learned way back in grade school, but when you multiply fractions, you just multiply across the top and across the bottom. So across the top, 1 times 1 times 4 is just 4. On the bottom, 2 times 4 is 8, times 9 is 72. And then that fraction will reduce. If you divide both top and bottom by 4, you would get 1 over 18. And so 1/18 square inches. So what that means is actually you can't even fit a whole square inch in that triangle. You can fit 1/18 of a square inch. All right, and then the last two are circles. And so we're going to do perimeter and area. Although for perimeter with a circle, we don't call it perimeter. We call it circumference. So the circumference of a circle, one formula to use is pi times diameter. And so 16 is the diameter. So my exact answer would be just 16 pi. I did not have to round. But then we also want to get an approximate answer for circumference. So I'll enter in my calculator 16 times pi, and I get 50.27 I'm going to round to. So 50.27 meters. Now we also need to do area. Area is pi r squared. And so that you need to know the radius. And so if you split 16 in half, you get a radius of 8. So pi 8 squared. And so the exact area is going to be 64 pi. 8 squared is 64. And that would be square meters. The approximate is if we type in 64 times pi, and you get 201.06 approximately. And I've noticed some people have been labeling their answers exact or approximate. You really shouldn't have to do that. If you make an equal sign, that means exactly equal. If you make an approximately equal sign, that's approximately. Plus, we can see the pi in your answer. So you really don't have to write anything more than this. And that's showing all of your answers. All right, last problem here. Another formula for circumference besides diameter times pi is 2 pi r. And I like to use that one when I'm given a radius instead of a diameter. So in this case, 2 pi 3. And if you multiply, you get 6 pi feet. That would be the exact circumference. If I multiply that out, 6 times pi, and I round, the circumference is approximately 18.85 square feet. And we'll do area. Area, of course, is pi r squared, so pi 3 squared. So the exact area is 9 pi square feet. And if I type 9 pi into my calculator, the approximate area is 28.27. So even though that circle looks kind of small in our paper, you could fit 28.27 1 by 1 foot squares in there. All right, that's it. Good luck in your studying.